The mission to Mars is basically 32 to 33 months. Once they close the door, it's just you and a few other people that are with you on a team. And it's a long time to be together with a small group of people in a really confined space with no privacy, very little contact with friends and family. You're really in what we would call an isolated, confined, and extreme environment. And so NASA's concern about a mission of this type and other long-duration missions is what will happen to think of it as the social bonding. We call it team cohesion, the glue that keeps team members bonded together. And that glue is really important because it's also what helps teams to be effective. So we do a lot of the research for NASA in what they would describe as analog environments, analogous to astronauts. So similar background, PhD level training, scientists, engineers, physicians. So the places where we've been studying teams for NASA are the Antarctic. So teams that go and spend 6 weeks camped on the ice in the Antarctic. And then one of the most interesting environments where we collect data is called high seas. And it's a habitat for a 6-person crew. It's at 8,200 feet on the side of Mount Mauna Loa on the big island of Hawaii. It is a very interesting habitat because it's in a lava field. So it looks a lot like a Mars surface. It's very similar in terms of the nature of the terrain. Somewhere in a 4 to 7 month range, one or more people start to desynchronize. They start to fall out of phase with the other team members in their cohesion ratings. And by the end of the mission, it's all hash, which means there is no team cohesion. You have different individual perceptions of cohesion, but that glue, that bonding that links people together as a cohesive unit, it's gone. And we've seen that in every one of those long duration missions. Actually use this device. It's a badge. It's a technology platform that has a sensor array in it, and it can detect the presence of other badges. And so basically, we collect other data. It has a heart rate monitor, so we can actually get some physiological indicators. And the goal with this would be to be able to identify who am I interacting with, and from the physiological signals, how am I reacting? Is this a positive interaction or is this a stressful negative interaction? And in that way, be able to, in effect, see how the team is doing, how it's functioning, pretty much in real time or very near real time, and then be able to give feedback to team members. But we're on the cusp of commercial space, the commercialization of space. CNBC predicts space industry is going to be $1 trillion industry by 2030. And there's no other $20 trillion industry at this particular point in time. So that suggests a real explosion in that. So right now we're talking about astronauts, but in in a decade, maybe a decade and a half, we could be talking about a sizable workforce in near and Earth orbit, maybe out mining asteroids, perhaps on the moon. And these people could potentially be supported by this kind of technology, or, this is early, or the follow-on technologies that would be built based on these concepts.